Greetings everyone, welcome to E&E Learning Hub, where today we're going to be looking at question 1 from the 2018 CSEC Electrical and Electronic Pass paper. All right, so let's begin. So part A, it says a 60 ohm fixed resistor is connected in series with a 40 ohm resistor, and a 12 volt DC source is connected across these two resistors. So part 1 of A, it says produce a neat sketch of the series circuit. All right, so let's go ahead and draw that series circuit. So we're going to lay out the resistors first. All right, so that's resistor R1 and this is resistor R2. So we're going to connect both resistors together, and then we're going to add our source. All right, so there we go. So it's just to add our labelings now and add the values for the resistors and the source. So the first resistor, we're going to call that resistor R1. That is equal to 60 ohm. The second resistor, we're going to call that resistor R2. That is equal to 40 ohm. And the voltage value for the source is 12 volt. All right, and here we have the series circuit. So that's it for part 1 of A. So for part 2 now, it says using the sketch drawn in A1, show how a multimeter should be correctly connected to measure the voltage drop across the 40 ohm resistor. All right, so to measure the voltage drop across the 40 ohm resistor, the meter must be connected in parallel with the 40 ohm resistor. All right, so we're gonna draw the sign for the meter. So a circle with a V in it, and then we're gonna have the connecting ends go across the resistor. So this is how would show how the meter would be connected to measure the voltage drop across the 40 ohm resistor. So keep in mind that whether it be a parallel circuit or a series circuit, whenever you're measuring voltage, the meter should be connected in parallel with the load or across the load. All right, so that's it for part 2. Now for part 3, it says calculate how much current will flow through the resistors. All right, so let's go ahead and get that done. So the first thing that we have to do is to calculate RT. So RT is equal to R1 plus R2, and that is 60 ohm plus 40 ohm. And that will give us 100 ohm for RT. All right, so now we can go ahead and calculate the current. So therefore, I is equal to V divided by R. So V was given from part A, which is 12 volts, and we just calculated R to be 100 ohm. So I is equal to 12 volts divided by 100 ohm, and that will give us 0.12 amp. So that's it for I. So that's the current that will be flowing through the resistors. All right, so let's move on to part 4 now of A. So it says to calculate the expected voltage drop across the 40 ohm resistor. All right, so to calculate the voltage drop across a 40 ohm resistor, so the formula V2, because that is R2 resistor, so V2 is equal to I times R2. All right, so that's the formula there. So we have 0.12 amp multiplied by 40 ohm. That should give us about 4.8 volt. So that would be the voltage drop across the 40 ohm resistor. All right, so that's it for part A. So let's move on to part B now. So part 1 of B says, state the names of the meters that are used to measure each of the following. All right, so to measure DC voltage, we would use a DC voltmeter. For AC current, would use a AC ammeter. For resistance, we use ohm meter to measure the resistance. And for electric power, we would use a watt meter to measure the power. All right, so that's it for part 1 of B. So part 2 says, state how the direction of conventional current flow compares with that of electron theory. All right, so conventional current flow is the flow of current from the positive terminal of a source to the negative terminal. All right, and that's it for conventional current flow. For electron theory now, electron theory is the flow of current from the negative terminal of a source to the positive terminal. All right, so that's it for both conventional current flow and electron theory. All right, so let's move on to part C. So it says a technician requires a 50 ohm resistor, but only has two 100 ohm resistors available. Design a circuit that demonstrates how the two resistors could be combined to give the required 50 ohm resistance. For the circuit, use VDC equal to 12 volts. You are expected to show the method for calculating the required resistance. All right, so for part C, we're going to do a trial and error. All right, because we're given two 100 ohm resistors, right? And the technician only requires 50 ohm. So it means that we'll have to design a circuit with a two 100 ohm resistor to give us 50 ohm. So let's go for the series circuit first. All right, so we're going to draw a series circuit with the two 100 ohm resistors, and let's see what the final value will be. All right, So here we have the circuit. So let's put in the values. So first resistor, 100 ohm. Second resistor, 100 ohm. And for the source, 12 volt. All right, so if we're to calculate RT, so that would be 100 ohm plus 100 ohm, and that will give us 200 ohm. All right, so looking at the final value here, we know that we cannot use a circuit because for the series circuit, for the final value, we are getting 200 ohm and the technician requires 50 ohm. So this is not the circuit that is required. All right. So let's try the parallel circuit. All right, so we're going to draw two resistors in parallel. All right, so that's the first resistor. All right, so let's connect both of them together. All right, let's connect the source now. All right, there we go. So let's add the resistor values now. So the first resistor is 100 ohm. Second resistor is also 100 ohm. All right, the voltage source is 12 volts. All right, good. All right, so let's calculate RT. So RT would be 100 ohm multiplied by 100 ohm. So we're using the product over sum method here, divided by 100 ohm plus 100 ohm. All right, so 100 ohm multiplied by 100 ohm, that will give us 10,000 ohm squared. All right, divided by 200 ohm. So 10,000 ohm squared divided by 200 ohm will give us 50 ohm. All right, so it means that this circuit here is best suited, all right, for the technician to get 50 ohm. All right, so that's it for this question.